Hello everyone, welcome to this channel. In the last video lecture, we have discussed about the various methods of disposal of municipal solid waste. So that municipal solid waste part was over. So today we'll move on to our next topic, that is air pollution. So what is air pollution? So air pollution is defined as the presence of any solid, liquid or gaseous substance, including noise. It is another part, noise, present in the atmosphere in such concentrations that may or tend to be injurious to human beings or other living creatures. Anything that is in excess which causes harm, whether it is present in the air, water, or land, is pollution. So, and the substances that cause the harm are called the pollutants. So, the solid, liquid, or gaseous substances which, when present in air, cause harmful effects on abiotic and biotic components. Abiotic means the non-living component, and biotic is the living component of any environment or ecology. Then these are called as pollutants. Okay. Now, uh, this is the basic description or the definition of your air. What is meant by air pollution? Now, air pollution can be natural or man-made. Now, it may be caused by naturally occurring events like volcanoes, which release huge amount of ash, dust, sulfur, and other gases into the atmosphere, or by forest fires. They may occasionally be caused by lightning, etc. So these are natural phenomena. This kind of the natural mode of air pollution is something that is caused by nature. You cannot help it, like eruption of volcano, or any active volcano that breaks out and its molten lava comes out, and it spreads over the surface or any ocean. Causes pollution, huge amount of pollution. In the same way, like forest fire, sometime in during rainy season, uh, huge lightning occurs, thunderstorms and lightning occur, and if a lightning strikes a tree, it might burn it up and then might cause fire. Like the recent example you can say of forest fire was the Amazon last year, I think, which killed a lot of wildlife in the Amazon, fire in the Amazon, and also in Australia. A lot of animals were killed. So this is something with that is done by the nature itself. But the more dangerous one is the pollution that is done by human activities. Now, human activities may be burning of fossil fuels, intentional burning of forests to clear land for urbanization or agriculture. Now, when air pollutants caused by the natural hazardous events tend to remain in the atmosphere for a shorter time, the air pollutants released by human activities may cause them to stay in the air for a longer time. So, natural pollution, when natural air pollution occurs, naturally resources, natural mode, the pollutants, such kind of pollutants, due to that mode, will remain in the air for a much shorter time. Whereas those pollutants which are present due to human activities, man-made air pollution, that those pollutants can cause much harm to the environment or the atmosphere. So this is the basic difference. Now let us move to the kind of pollutants that we have for air pollution. Now the atmosphere may contain hundreds of air pollutants from natural or anthropogenic or man-made sources. Now, all these pollutants, which are emitted directly from the identifiable sources, either from the natural hazardous events like dust storms, volcanoes, etc., or from the human activity like burning of coal, wood, oils in homes, industries, automobiles, etc. And these are called as primary pollutants. So directly that is coming into the atmosphere from the exhaust of chimneys and factories and whatnot, cars. Automobile is also a major contributor of air pollutions. So the more the boom in the automobile industry, the more the air pollutants. This is the reason why we have opt for we have opted for your CNG instead of petrol and diesel engines in the vehicles. Most of in highly polluted cities like in Delhi or in NCR, you'll find they have replaced the engines by CNG in order to cause less pollution to the atmosphere. Like the air quality here in those cities, like in Delhi, the air quality is disastrous. So every time near Diwali, you will find this quality of air to be deteriorating severely. So this happens, and not only in Delhi, in many, even in most of the A-class metro cities, such is the condition. Maybe not up to the extent in which it has hampered in Delhi, but in other cities also, the air quality index is also quite high, quite high. So the pollutants that we will be discussing here are the primary air pollutants, which includes oxides of sulfur like sulfur dioxide, sulfur trioxide, okay, oxides of carbon like carbon monoxide and carbon dioxide. These are the two main components of carbon oxides, phase of carbon. Oxides of nitrogen like nitrogen oxide, nitrogen dioxide, nitrogen trioxide. So volatile organic compounds like hydrocarbons, okay, and suspended particulate matter like SPM, which is in short called SPM. These are your primary pollutants. Some other air pollutants, primary pollutants also include hydrogen sulfide gas, hydrogen fluorides, methyl and ethyl mercaptans, etc. Okay. Now, what is the secondary pollutant? Now, these primary pollutants often react with one another or with water with the help of sunlight to form entirely new set of pollutants which are called as secondary pollutants. Now, what happens? Some of these air pollutants like carbon dioxide reacts with oxygen forms carbon monoxide reacts with oxygen forms carbon dioxide or with ozone also sometimes. So some of these primary pollutants react with themselves to form secondary pollutants. The secondary pollutants will include examples like sulfuric acid, ozone, so formaldehydes, pan. This is another very important secondary pollutant. This is peroxyacetyl nitrate, hydrocarbon organic compound. Okay, these new pollutants are even more harmful than the primary pollutants. So now suppose for example H2SO4 is formed by simple reaction between sulfur dioxide and water vapor. Okay, now suppose let us take this example of sulfur dioxide. What happens when it reacts with water from H2SO4, which is sulfuric acid? It causes acid rain. The deterioration of marble in Taj Mahal has also occurred because of this acid rain. Many such places which contains uh, uh, white marble or white any stone, uh, white kind of a stone. So there the deterioration of color has occurred due to acid rain. So it is harmful even to plants or animals. Also they are harmful. So even the secondary pollutants are more harmful than the primary one. So other secondary pollutants like ozone, formaldehyde, and PAN, etc., are formed by photochemical reactions. Okay, in presence of sunlight, like one molecule of oxygen and one molecule of uh, nascent oxygen. Okay, just nascent oxygen, they will react in presence of sunlight to form ozone. The ozone forms in the layers of atmosphere. Ozone is a very important part of the atmosphere, which kind of protects the ultraviolet and the ultraviolet and the infrared radiations from entering into the atmosphere. If they start entering the atmosphere, you cannot go out in broad daylight or in sunlight. It will cause harm to your skin or might cause you on skin cancer. So but another important thing that is to be noted here is the depletion of ozone layer has started in places in near the polar regions like in Antarctica. So what happens when the depletion of ozone layer starts? The sunlight will pass through the depleted area, the holes. When there are holes in the ozone layer, sunlight will pass through alpha red and infrared radiation, which were not supposed to enter the atmosphere. They're entering and they're causing huge harm, leading to melting of the ice caps. When ice caps melt, your sea level will rise. And later, if this process continues, then it may lead to submergence of many many cities which are lying along the coastline. Like for instance, there is a danger of submergence for the city of Mumbai or Chennai, which are along the coastline. So you can see the link, the connection of the atmosphere to how the atmosphere how the healthy condition of atmosphere is very essential for the future life, for the future prospects. Now we'll discuss some of these oxides and what are their characteristics and what are the harmful effects. it can cause. Some of these pollutants we'll discuss. Let us take, for example, sulfur dioxide. Now, sulfur dioxide is the basic air pollutant among all oxides of sulfur. Now, sulfur dioxide is an irritant gas, and when inhaled, it affects our mucous membrane. Okay, so it increases the breathing rate and causes oxygen deficits in the body, leading to bronchial spasms in some of the affected persons. The patients of asthma are badly affected by this pollutant. So mainly it will lead to your respiratory. In short and simple words, if I had to describe this pollutant, this very particular pollutant called SO2 will lead to problems in your respiratory systems. It might cause like the risk of asthma patients will be very high in such cases. Some quantity of the atmospheric sulfur dioxide may oxidize to form sulfur trioxide. Sulfur trioxide is another primary pollutant, which when inhaled may dissolve in the body fluids to form sulfuric acid, which is a very strong corrosive acid. Again, it will lead to bronchospasm. Bronchospasm is the deposition of certain suspended pollutants in the air in the bronchioles of the lungs. So if it happens, it will choke down the bronchioles. Air cannot enter, blood cannot enter there, leading to other problems. So it is SO2 is also responsible for causing acidity in fogs and smokes. Okay, mainly originates in the atmosphere air from refineries, chemical plants, smelting operations, and burning of fossil fuels. Open burning of garbage as well as municipal incineration plants may also emit sulfur dioxide. Now, as per the PIS standards, revised PIS standards of the National Air Quality Index, the concentration, maximum permissible concentration of sulfur dioxide pollutant is 50 microgram per millimeter cube, which approximates to 0.019 ppm at 20 degrees centigrade. So this will discuss the subsequent topics. So what are the permissible limits of pollutant concentration in the atmosphere. So another important your pollutant is carbon monoxide, which is a colorless, odorless, and toxic gas, and produced when organic materials like natural gas, coal, or wood are not incompletely burned. Okay, so what happens during incomplete combustion? Your carbon monoxide gas will be released. If the combustion is complete, then it will release CO2. This I think you know already in your basic science. You have learned all these things. So vehicular exhausts are single largest source of carbon monoxide, as the number of vehicles have increased, and it's increasing by leaps and bounds. So poorly maintained vehicles having insufficient engines without having fitted with adequate pollution control devices will release greater amounts of carbon monoxide. Now, carbon monoxide is another gas which has the affinity to combine with hemoglobin to form carboxyhemoglobin. Okay, this is a very stable compound, and if carbon monoxide is inhaled after forming of carboxyhemoglobin, the oxygen content in the blood will reduce, leading to the death of the person. So sometimes there have been cases where the person during any winter season or at night, if there is a closed room and you are burning piece of wood or charcoal, anything, and which is not completely burned, it will lead to release of carbon monoxide. And if there are not sufficient exhaust from their room, and if the person inhales that, it may lead to his death. So there have been instances like that in the past. So eventually, when inhaled, CO will replace oxygen from hemoglobin and forms the, as I told, from the carboxyhemoglobin. So low levels of carbon CO inhalations produce symptoms like headache, dizziness, reduction in reaction time, etc. Okay. So and sometimes also leading to death, as I told us in the example. So headache, dizziness, reduction in reaction time. These are some of the palpitation, nausea, heart palpitations, difficulty in breathing. These are some of the symptoms or the health problems that are caused due to oxides of carbon, that is carbon monoxide. And it's not a permanent pollutant. Fortunately, it's not a permanent pollutant. There are some natural processes which will convert carbon monoxide into carbon dioxide if it is in the atmosphere. So it doesn't stay for a much longer time. So in cities having higher number of automobiles and industries, CO is found in high concentration up to 60 milligram per meter cube, which is approximately 54 ppm, with still higher concentration in tunnels, garages, and near road intersections. So now oxides of nitrogen, that is your nitrogen monoxide, dioxide, and trioxide. Atmospheric nitrogen may combine with oxygen at higher temperature as generated during fuel combustion due to nitric oxide, nitrogen monoxide or nitric oxide you can say. So nitric oxide at low levels is relatively harmless. Okay, it's not that harmful, but at higher concentration may cause asphyxiation and respiratory discomfort. Okay, it will lead to respiratory problems because it combines about 3 lakh times faster with hemoglobin than oxygen. Again, it will lead to same conditions as in case of carbon monoxide. So larger concentration may lead to quick deaths also. So main eye and nasal irritations and respiratory discomforts, even deaths are also caused by nitric oxide. Prolonged exposure to higher concentration of Na2 exceeding the permissible concentration can also cause serious diseases like emphysema, which is swelling due to air in body tissue. So body tissue will start swelling. This is in medical term. This is called as emphysema. So it increased and also might increase the susceptibility to pneumonia and even lung cancer. You can see how what kind of a dangerous pollutant it can lead to. So as per the PIS standards, 40 microgram per meter cube is the maximum concentration, annual concentration for nitrogen dioxide. Okay, hydrocarbons. Next are the volatile organic compounds like hydrocarbons. So hydrocarbons are group of compounds which consist of carbon and hydrogen atoms. Now they are either evaporated into the atmosphere from the petroleum fuel supplies such as petrol and diesel, or are emitted out in the automobile exhaust as the remnants of petroleum fuel that did not burn completely. Now, hydrocarbons may therefore be always contained in the smokes of incinerator using petroleum fuel for burning, and also sometimes in refineries. Okay, so in any refinery, some of you have visited the refineries, you will see there's always at every particular instant of time. Even this method have already been also now employed in many uh, traffic signals also in large cities like Hyderabad or Mumbai. You can see the concentration of each of these pollutants that I have explained here. Each of these uh, pollutants having what is the concentration right now, instantaneous concentration, that is what is the condition that will be displayed in a LED kind of a digital display board. You'll feel, and this happens in traffic signals. In large cities, they have done that so as to know that it should not cross beyond the permissible limits. Again, hydrocarbons mainly source will be refineries, incomplete combustions in case of um, your automobiles, engines from the automobiles like petrols and diesel. And hydrocarbons are washed out of the air when it rains also and run into the surface water. In low concentration and when washed away in quick succession by rains, they do not generally cause much harm. But in higher concentration, they may cause irritation of eyes, respiratory tract. At least 8 of them have been responsible for causing body cancer. So again, they are, uh, they have also proved to be quite harmful if consumed in higher concentration. Hydrocarbons have been divided into aliphatic or aromatic. Aromatic is the benzene ring kind of a structure that you've learned in organic chemistry. Aliphatic is the normal alkynes, alkanes, and all that. So hydrocarbons are chiefly released into the atmosphere by automobile exhaust. Paraffins and olefins have been found to be chief hydrocarbons present in large quantities in the air, where heavy number of automobiles fly every day. Okay, so as per the air quality standards, its maximum limit is 160 microgram per meter cube or 0.24 ppm. Now, aldehydes, ketones are also considered under hydrocarbons because they are formed by photochemical oxidation of hydrocarbons as secondary pollutants in the atmosphere, although they may also be released by automobiles and incinerators along with hydrocarbons. So substances like formaldehydes, okay, and formaldehydes, aldehydes. Formaldehyde is a kind of aldehyde, and the category falls under the category of aldehyde organic compound. It causes irritation of eyes, skins, and lungs, and hence may be quite injurious to health. So another final primary pollutant will be your suspended particulate matter. Mist. Mist meaning aerosols consisting of liquid droplets. Fog. Aerosols consisting of water droplets. Okay, and these are liquid particles that comes under suspended matter. So this particulate matter in the air may occur largely in solid form, such as dust, smoke, fumes, and these are all, this comes under SPM, that is suspended particulate matter. So this is the solid part. Liquid part consists of mist and fog, which may be in vapor form or in liquid form. Okay. So the total TSPM is the total suspended particulate matter in air. And like for mist and smog, examples can be the source from the sulfuric acid mist. Then for solid particles, dust storm. For smoke and fumes, cigarette smoke, smoke from the burning of garbage, etc. And fumes is the zinc and lead fumes. Okay, this completes the primary pollutants. Secondary pollutants, as I already explained, sulfuric acid is formed with the reaction of sulfur dioxide and water vapor present in the air. And when it rains, it comes as an acid, which is called as acid rain. Ozone by photochemical reaction of nascent oxygen and oxygen. So nascent oxygen is unstable, a single atom of oxygen, which reacts with one molecule of oxygen to form this ozone. Again, this is a reversible reaction. Okay, all photochemical reactions are always reversible reactions. So again, formaldehyde I have already explained, and peroxyacetyl nitrate. This is again another hydrocarbon. Carbon is a major secondary pollutant present. Allergic agents might also be present there. Okay. Now another important you can say effect for these pollutants are the photochemical smoke. What is photochemical smoke? And the production of PAN and ozone. Now smoke. What is smoke? Smoke is a mixture of smoke and fog. Okay, so it can be of two types: photochemical and coal induced. The smoke can be due to the reaction of due to some photochemical reactions or due to coal, burning of coal. The atmospheric conditions favorable for the formation of photochemical smoke are the presence of high concentration of hydrocarbons and nitrogen oxides in the atmosphere, gas stagnation, and not to cause dispersion of air pollutants. And second, abundant sunlight. So all, remember one thing, for this photochemical reactions to occur, the presence of sunlight is mandatory. Without sunlight, any photochemical reaction, that is why it is called as photochemical reaction, because photons are induced and photons will come from the light, that is the sunlight. So here light or sunlight plays a major role in such reactions. Okay. The formation of photochemical smoke is restricted to highly motorized cities where plying of motor vehicle is more. And smoke is caused by interaction of some hydrocarbons and oxidants like sulfur dioxide or nitrous oxides under the influence of sunlight, and it forms, leading to a formation of dangerous compound that is called as peroxyacetyl nitrate. In short, it is called as PAN. The main constituents are nitrogen dioxide, hydrocarbons, and carbon monoxide, and large quantity of ozone. PAN in itself is an extremely harmful gas. The ozone gas is also quite harmful in the respiratory system. So at concentration of 0.3 ppm, cough and chest discomfort is increased. Okay, for such PAN compounds. Okay. Now, as per the new revised air quality standards, the maximum permissible concentration of ozone on hourly weighted average basis is 180 microgram per meter cube for residential areas. Now, as we have discussed all the effects of air pollution on humans, mainly it will damage the respiratory system. So if your respiratory system it starts damaging the respiratory system, causes diseases like irritation, asthma, and even pneumonia and lung cancer. All pulmonary diseases might be stimulated because of this air pollution. Okay, so smoking cigarette is not the only cause for causing lung cancer. This inhaling such bad air quality like the one in Delhi, it happened few months back that air quality index in Delhi has rose to 1200 something, which is 3 times or 4 times higher than the normal permissible limit, which indicates that if you inhale a quality of air, such bad quality air, it is equivalent to smoking 60 cigarettes in a day. So imagine the kind of harm it can cause to your lungs and uh, your respiratory system. Much effect it can cause, effect of air pollution. Now on plants and animals also, they have drastic effects of air pollution. The adverse impacts of the pollution are accordingly are not, and quite obviously not related to human health, but plants and animals are also detrimentally affected by air pollutants. The most prominent air pollutant which cause severe damage to plant is fluorine. Now, fluorine is emitted from factories manufacturing aluminum, glass, and phosphate fertilizers, and in some clay baking operations. The concentration of fluorine in excess of zero point 0.3 microgram per millimeter cube cause phytotoxicological effects on plants. Frequently, the plant damage is observed in the fruit or the flower, either of which significantly lowers the value of crop. So the flower or the fruit portion will be affected because of large concentration of fluorine. So fluorine is one major uh, air pollutant regarding plants. Okay. So but the most obvious damage caused by general air pollutants like sulfur dioxide, hydrogen fluoride, HCl, chlorine, ozone, nitrous oxide, ammonia, mercury, and all this, etc. to plants and vegetation occurs in the leaf structure. So not only the fruit or the flower, but the leaf is also severely damaged sometimes. Again, animals also, like arsenic and lead can cause uh, huge damage to uh, the digestive tract in animals, complete loss of appetite and diarrhea. So livestock animals may also be affected severely because due to greater consumption of such harmful pollutants like arsenic and lead. So in case of plant, it is fluorine. In case of animals, it is arsenic and lead. So this completes the characteristics of the effects of the different pollutants that I have explained here. Now, the air quality index. This is the BI standards. You can say air quality index. This is given in a tabular form. Like for sulfur dioxide, this is given every values are given in microgram per meter cube. So it is in industrial areas it is 50. Okay, and ecologically sensitive area it is 20, right? So annual it is 50 and 24 hours it is 80. Annual will be obviously annual values will more down because it's annual average taken, and 24 hours means for one day it is being taken. Similarly, for nitrogen dioxide NO2, it is 40 annual, 24 hours is 80. So you have 80 and 80. 20, if we go by only the 24 hours statistics, then you have 80 for both industrial and ecologically sensitive area. SPM, particulate matter, it is 100, 24 hours and 100. Okay. Particulate matter size less than 2.5 micron. So it is finer particulate matter. So this is the finer one is the more serious problem causing pollutant because it enters the bronchioles of the lungs. So this is why the problem might start here from here. So 60, 60. So you can see the limit here is being lowered from 100 to 60. This is the reason. Then we move on to ozone. Ozone again in 8 hours and 1 hour. It's because of photochemical. Ozone is quite unstable. First, let us understand this. That ozone is quite unstable. So you cannot measure this concentration for 24 hours. You have to do it whether the time index, the time span has to be reduced. So it is based on 8 hours and 1 hour. Okay, so 100, 100 and 180, 180. Lead again for animals. Lead concentration will be 0.5 and 1, 24 hours is 1. And in the last column also, it is given the method of measurement, how the measurement is being done. So there are like gravimetric, TOEM, beta attenuation. So there are some devices which measure the air pollutants. So for different gases, different air pollutants, you have different methods or different equipments to measure it. Carbon monoxide, 8 hours, again quite unstable. So 8 hours and 1 hour. Again, it is C. It is only 2, and for 1 hour it is only 4. So ammonia, 100 and 400. Ammonia will be more quite stable gas. So here you have to understand the unstable gas will be having for annual and 24 hours, but the stable one, and the unstable gases will have only, like for case of ozone and carbon dioxide, it will be measured in 8 hourly index or 1 hourly index. Okay? Benzene annually quite stable. Benzopyrene, these are aromatic compounds, so falls in hydrocarbon category. These are the limits. We'll go through this table to understand these limits. So this is all for today's video. In the next class, we'll discuss. I'll give you certain, maybe I'll give you certain PPT, or we might discuss about the disaster management. That is the last final topic that is being pending in this unit. And with that, we'll complete our entire course. So thank you for listening to this video.